Hello everyone, good morning. We will begin momentarily in about 10 minutes, so thank you for your patience. All right, everyone, thank you for joining us today morning and for our technical webinar today on the Innovative Duct System for Sustainable Buildings by EGBC member KIMMCO-ISOVER. So just before we begin, let me make a couple of introductions. My name is Jason John and I work for the Emirates Green Building Council and I work as the technical engineer. I will be the moderator for today's session and I will be introducing our facilitators for today's workshop. So in case you're joining us for the first time, the Emirates Green Building Council is a membership-driven non-profit organization with the goal of advancing green building principles and protecting the environment and ensuring sustainability in the UAE. Our vision is for the UAE to be the global leader for sustainability in the built environment, and we do this by acting as a catalyst for collaboration and as a hub for excellence to promote sustainability of the built environment. A bit of housekeeping as we begin. So for those of you who are using this platform, GoToWebinar for the first time, you are all muted and you will remain muted for the entirety of the webinar. So there are no verbal questions that will be asked, but we encourage you to ask questions via the questions chat tab on your right-hand side in the control panel. So if you have any questions during the webinar that come up, please feel free to ask them. The team here at Emirates Green Building Council, we will be monitoring the questions as they come in and we will flag them for a Q&A and discussion session at the end of the presentation. So if you have any questions that come up, please do feel free to ask them. We will be sharing the recording of the presentation and the workshop after the webinar is done. So be sure to keep an eye out for that. Also, please do complete the survey as you exit the webinar, as this informs us for our upcoming workshops and what topics and suggestions we should cover for future events. And finally, follow us at EmiratesGBC on our social media to keep up to date for upcoming events, workshops, and announcements. So without further ado, I shall be introducing our facilitator for today, Mr. Satish Vincent, who is the Assistant Managing for KIMMCO-ISOVER. Satish is a mechanical engineer and postgraduate with over 10 years of experience in the mineral wool installation industry in the field of technical marketing. He is currently located in Kuwait and working under marketing department handling HVAC portfolio for KIMMCO-ISOVER. So Satish, I will now be handing over controls to you. So you should be able to share your presentation now. So the floor is yours.
Thanks, Jason. I hope you can see my screen now.
Absolutely.
Yes, thank you. Thank you again, Jason, for your kind words, and thanks for ECBC for giving us this opportunity. And good morning to everyone. Thanks for joining in this morning. We'll be having a very interesting 45 minutes, 40 to 50 minutes. And I'm Satish, as Satish Vincent, as Jason was just introducing me. I'm currently sitting in Kuwait, where we manufacture a glass wool. We have two plants, a plant in Kuwait, which produces glass wool, and we also have a plant in Saudi Arabia, which produces stone wool. For the people who don't know about KIMMCO-ISOVER, we are a joint venture company between Saint-Gobain, a French-based company, and Alganem Industries, a Kuwait-based MNC. Okay, today I'm joined by Ashok, the specification manager. He's based out of UAE. We too will be taking the presentation going forward. Okay, with this brief introduction, I try to move the screen. And there's a technical. Okay. On today's agenda, we will be talking a little bit about the importance of fire safety in sustainable buildings or green buildings, and then we will be talking more detail about the innovative duct solutions which we are proposing for, or which we are promoting for sustainable buildings. Okay, now let's get into the topics. As you know, energy efficiency is one of the critical criteria in achieving our goal for mitigating global warming, or let's say green. But why energy efficiency? Because it helps us in both ways. It helps to save carbon footprints at the plant level, where plant level, when I say it is power plants, and also in the places where we consume this energy. Maybe the plants, the equipments and the plants that uses this energy, there is also carbon pollution. We can, once we have efficiency, we can achieve carbon neutrals in these two places, production place as well as in the usage place. Now, if you see where this energy lies, or which is the segment that consumes most of this energy, as you are aware, you might have seen this slide many a times. Building consumes close to 36% of global energy, and it emits close to 28% of the emission. Now, we drill down, energy efficiency is important. Then we saw where is this energy consumed most, that is in the building. Now, if we drill further down, where in the building is this energy lies, or where in this building is the energy that is consumed most? If you see that, it is in the HVAC. Yes, ladies and gentlemen, close to 60% of total energy that is consumed in a building goes to HVAC. And it is even more higher in GCC, which is around 70%. I'm sure this number is a little bit higher in regions like Kuwait, where we use HVAC for more than 10 months a year. And definitely this number is quite high. And if you do little maths, if you go back and see, HVAC consumes close to 18 to 19% of total energy that is produced in the world. That's quite a significant number. Now, we all know that. That's why the green building is quite important in achieving our objective of mitigating the climate change. The other day, I was discussing this with my colleague that about the green building concepts. Immediately, she told, no, this is not anymore a concept. This has gone from the concept to design to implementation. I totally agree with her. The pace has increased. Maybe a small country to the bigger country, everybody are interested with green buildings. They know the benefits of green buildings, and the green building momentum is taking up. It's booming. So one of the studies says that in next 6 to 7 years, the global building material market can go up to 80%. And insulation alone, it's going to go by 5% every year. Now this momentum is going. Along with that, we also see a change in the way it is looked at it. Now people have become more important. Sorry, people have become more important. And earlier we were looking about building to be insulated, late in 1930s. Then people started looking at more efficient buildings in 1970s, where along with insulation, we are looking about efficient buildings in the insulation. Now in the era where we are looking on sustainable buildings, what does this mean? That now people are looking for more comfort. People are looking for acoustics. People are looking for indoor air quality and safety. There are many other components that are joining into this sustainability building. It's no more just an insulation. Now, what you call the comfort is no more a luxury. It's a necessity. People wants to have a healthy well-being, and it is all revolving around people. It is evolving. The type of building is evolving. All good. If you look into this, when we make into a green building, we get in eco-friendly products into this system. We look for the solutions that are energy efficient and healthy. Very good. This is all required to achieve a green building. But we should not forget to look into the fire factors when we are selecting these building products or solutions. That is where we are coming into it. Yes, right now we know that green building is critical for in our journey towards green. Yes, to achieve this, we are using the best products and solutions which can help us to achieve our goals. That is also very good. That along with that, it is also necessary for us to include fire criteria in our thinking when we are looking about selecting these products or solutions. Okay. I'll try to move to the next slide. Okay, I like to establish a risk factor on sustainable buildings. This study emphasizes what we discussed earlier. An additional importance for fire safety, especially if it is a green building. In this article, it is very beautiful. There is a smoke which adds carbon dioxide to it, carbon to the atmosphere. It releases carbon. Yes, another component. And water pollution, because once they use this water, it will carry the debris, it will carry the chemicals that is mixed in the products that are used in the buildings. Water pollution. Then you have the debris and you have wastage. And over and above that, once you start to rebuild this, demolish a portion of the building that's been got in the fire, when you demolish that, then you want to rebuild it, you're adding more carbon to it. This can go up to 14% of it. Now, this article also states that 30 to 40% of 30 to 40 kgs of carbon is released for every square meter of a building which is burnt. Interesting. Ladies and gentlemen, I like to take your notice here. When we were doing this study,
Satish, hello. Apologies, everyone. I believe Satish is
we
having
just
some
checked down
technical
in
issues.
UAE.
Satish, hello, can you hear me?
In 2019, interesting, in 2019, there were close to 89,000 fire incidents. Fire all had as this fired up in fire. Just people really page it. 30 per year. Wait like 1,000. A create. If you have a regular building, we have to be extra careful. And the last but not the least, there's a very important conclusion that report, the influence of fire factor on sustainable buildings. It talks that when you try to improve the energy efficiency
Hi everyone. Sorry, we are just trying to sort this out. Please bear with us because I think the connection just dropped on the facilitator's side. So we'll just try to get him back online again. So please bear with us for about 5 minutes.
Building, one of the best and easy way or a right way is to look for building envelope to insulate the walls and the roofs of the building. But in the process, if you don't select the right materials in the system without considering the 5 factors of it, it definitely adds the fuel to it.
Apologies, everyone. Thank you for your patience. I just spoke with the facilitator. He will be just logging back in a few moments. So please bear with us.
Hey, Jason?
Hi, Satish. Thank you for joining us again. Uh, Let me make
I
it.
don't know till where I did I present it, but I'll take Ashok's idea. Ashok, just can you help me out? I was without knowing
Yeah,
this, I was just
Satish, you have to go back to the FM Global report.
okay.
You
Okay,
were
good.
you
Thanks.
had just explained what is the criteria which is not being met and how it is being defined.
Okay,
You've already shown the audience that the green buildings cover all the major factors, but the new concept which is coming in is that you have to take care of fire property also. So that from that
right,
slide on, you can explain.
right.
Satish, you'll have to share
Slide?
your slide again. Um,
Is that okay? Show my screen. Yes.
yeah.
The next slide.
Okay. Uh, is this one, Ashok?
No, one more. Yeah, that's the
Okay.
one.
Sorry again for the people for the technical issues that we are facing here. Okay, let's not lose the focus on this. This is a very interesting topic that I really wanted to spend time on this. This is one of the key slides that we wanted to share with you people to show the importance of fire safety in green buildings. I don't mind repeating the slides, but I want this to be one of the key takeaways from this presentation. Okay, let's go on. Now, as we mentioned in our previous slide, that it is quite important to consider fire safety in green buildings, along with the other factors that we already discussed, like healthy products or sustainable products or sustainable designs. Along with that, considering the fire safety is also important. Now, this is re-emphasized in the report that is published by FM Global in the technical report, which is named "The Influence of Risk Factor on Sustainable Buildings." In this in this article, they very beautifully explain how this happens in a fire, in a building. In case if there's a fire, there's a common emission in every building, right throughout its operation, right throughout its lifetime. The carbon footprints are there during constructions, there is during their operation, and also at the demolition stages. But if any building encounters a fire during its operations, it adds additional 14%, up to 14% of carbon into this. Now take a pause and look at it. Where is this pollution that is possible? How it can increase 14%? One is, we spoke about smoke. Definitely, immediately that comes into our mind is smoke. Yes, and water. Yes, in water it is two. One is water wastage and water pollution, because once they use this water, it carries the wastewater carries the debris along with that, the additional minerals and other chemicals that is mixed in the building, that is used for the making of building materials. Those chemicals get mixed with these water and adds the pollution to it. After that, think about demolishing the the building that put into fire. Portion of that building has to be demolished, those wastage, then we have to rebuild such buildings. So there is definitely carbon addition, and this can go up to 14%. And this article also states that close to 30 to 40 kgs of carbon is released for every square meter of building is burned. This is interesting. If you look this into the calculation terms, in 2019, UAE had a close to 90,000 fire incident calls. 90,000 fire incident calls, and thank God, but not all, fortunately, all not end up in building fire. But if you, for our calculations, if you assume that this have ended up in a fire, of a building fire, which is just around 30 square meters, 90,000 fires, about 30 square meter building, then this would have released close to 0.1 billion kgs of carbon dioxide into the air. When we translate this into some realistic, some numbers which we can visualize, it is something like running 20,000 cars, for 1 year. And if you look at the water, it is something like 32,000 people's daily consumption for a year. That is a scale of carbon footprints that a building can leave behind once you have a fire in a building. Okay, another important conclusion from this report is that when you try to improve the efficiency of the building, sustainability of the building, by improving the energy efficiency alone, without considering the fire factors, then such kind of a building can be 3 times more riskier to fire. I'll repeat. When you try to improve the sustainability of the building only by improving the energy efficiency of the building, without considering the fire factor into it, such kind of a building can increase the risk of the fire risk of that building by 3 times. This statement is very beautifully explained in one of the book released by Jim Tedwell, Bridging the Gap Between Fire Safety and Green Buildings. Very nice article there, really explains how this can happen. And in that book, they have given 2 examples. I like to list out one. One is on the facade. Imagine that we want to improve the sustainability of the building, so we want to improve the energy efficiency. So one of the best and the good way is to have the building envelope insulation. That is, the entire outside wall of the building has to be insulated, and the roofs. Okay, very good. Now, if we consider in doing so, we will consider some U value calculations, some thickness calculations, all good. But if you don't consider the fire factor into that, and if you don't select the right system in the product, then we are adding fuel to the building, and the risk of such building can go up. Right, especially if you're looking at ethics, it can be very deceptive, because from outside it might look the wall is having its integrity. But if a firefighter, for example, if he wants to take the support of such kind of a building, it is going to collapse. But the inside core material, if it is not stable, it is catastrophic. Another example which they cite is on the lightweight construction. Again, it's a very good sustainable product solution where we can save a lot of carbon footprints. But if you don't select the right materials, right systems, even those materials can be a catastrophe. See, the point here is that we should not use ethics or we should not use lightweight construction. Definitely, that's not the point here. Point is that definitely these are the best solutions for green building. Along with that, please consider fire risk factors. Try to find the products and solutions which has a better resistance to fire or better performance against fire. That is what we want to bring into this. Okay, now this gets into a big challenge. This is a growing challenge for the engineers and consultants. It's also challenging for building material manufacturers like us. Let me talk for us. I'm quite proud to be associated with KIMMCO because KIMMCO-ISOVER because the parent companies are very strong in sustainability. And we are trying to develop innovative products and develop our own products so that it can meet the green building requirements. And the products and solutions which we develop has to be flexible enough for the designers without compromising or without adding the cost and the fast installation or fast things to complete the building. Now, this is also a challenge for the engineers, and adding to that is the fire. We are taking extra care to produce a product and solutions which can meet all these things. Now, there's a tip for consultants and architects. This is simple, it's pretty easy, that how we can find a product and solution which is fire safe, or how we can consider. The easy thing is that you have to understand the fire behavior of the building materials and systems. Now, to understand this, let us see a little bit of smoke and fire, then we'll get into much more details. This slide, you might have, this slogan at least you might have heard many a times: smoke is more fatal than fire, especially in GCC. The other day we were discussing, and it was told that this topic is quite often everywhere in UAE. It's a very good topic, there's no doubt about it, and it is, the awareness is very critical. But I don't know, the causes is something I don't know whether you have heard about it. But if you try to group the casualties in a smoke, you can categorize, in a fire, you can categorize in this eight categories, which is mentioned here. If any casualty happens, it can be categorized in one among these 8 categories. And if you see, smoke has a role in almost every category. Smoke has a role in every category. I think it was in month of November, the building in which I was staying, the 4 floors above my building, there was a small fire. Fortunately, thank God, it was just a room fire. And we were asked to evacuate. It was early in the morning, 2 a.m., and family were walking down the corridor. I tell you, ladies and gentlemen, it's quite difficult to breathe, even though we are 4 floors below. And thank God it was not a big fire where the firefighters were efficient to put it off very fast. But still, as I was walking through the corridor, I can feel the smell of the smoke. I can feel the ashes in my breathing. I mean, it gets really suffocated when we walk down that corridor. Then it was really forcing me to take an extra air to breathe. Yes, the point here is that smoke is critical. What we like to emphasize here is that we should know a little bit about the fire behavior of the building materials. When it comes to the fire, what kind of smoke it can release, or at least what is the quantity of smoke that can release. It is important for us to understand when we are finding when you are selecting the right insulation or right any building materials. Okay, next point is on the fire. If any product that burns goes through a process, that is, it has a starting ignition process, then the slow growth, then the fast growth, and it completely burns. It burns as long as it has sufficient fuel, sufficient oxygen, and sufficient temperature. After it burns, or after one of this gets over, it starts to cool down. This is the normal process. We'll try to see a little more detail about this in the next slide. Imagine this is the ignition stage. What you see here, I hope so you can see my cursor. You can see a small fire that is ignited on the chair or the sofa here. Then this is slowly burning. It is getting momentum, and now it is a fast growing stage. Now, if you keep observing in all these 3 stages, you can see the materials are getting burnt, which are coming in contact with the flame. I'll repeat, all the materials that are burning here or the material that has come in contact with the flame. But this is a time that is where we can do the firefighting work. The sprinkler comes into picture, or the fire extinguisher comes into the picture. We can start to evacuate people from this room to or a safer place, or the firefighters can come and work. We can reduce the growth. We can do a lot of activities during this work to save the building or to save the people or the properties. But once we have the flashover, I try to play this video. Okay, once you have the flashover, what is a flashover point? This is a point in the fire curve where the entire building starts to burn before it comes in contact with the flame. I repeat, imagine there's a paper in the corner of the room. There's a paper in the corner of the room somewhere that side, and this is not coming in contact with the flame, but the temperature in the room is so high that the paper starts to burn itself before it coming into contact with the flame. That is called the flashover point. Once the flashover point happens, as the temperature keeps on increasing, the entire building starts to burn, and it is going to burn so vigorously, and it will take into a full development stage after this. After this point, there is no opportunity of saving the people inside it or the material inside the building. After this point, it is all about wait and watch. We are more looking into saving this building or preventing the fire spread from this room to the next room. It is all up to the compartmentation. Here we talk about the fire-rated walls, fire-rated ducts, all those things will come into picture. But saving the people or the property inside the room where the fire happened is over. We cannot do anything. So in short, in case if you want to have a in short, what is that we want to say here is that the more time you have it to achieve the flashover point, we have more time to act with the people, right? If you have more time to reach the flashover point, you have more time to evacuate people. You can ask people, firefighters, to come and operate on it, or we can save the property of the building. But once the fire reaches the flashover point, and once the flashover point happens, it is end of that activity. We cannot make any kind of an firefighting activity inside the building. The more it goes into protecting the rest of the part of the building, the other part of the building. So flashover point is a very critical in understanding what is the flashover point of the material is very critical in finding our right building material. See, okay, now we are coming from insulation background, and what is our recommendation? Our recommendation is that at least look for a material which has no flashover point. If you test the insulation material as per EN standard 13501, it lists down what is the flashover point of each material. Especially I'm talking for insulation, so insulation material. It classifies into A, A1, A2, B, C, D, E, and F. Our recommendation is that at least look for a material which falls under class B, which means that there's no flashover. Then you have a lot of time, or it gives an additional time for you to evacuate people, and you can start your extinguishing process. You need not depend on the what you call fire-rated walls or the ducts. You have a sufficient time, or it can give you sufficient time for you to have the evacuation. At least it can give you an additional vital extra minute, which is very critical in the event of fire for people to be evacuated or the property to be saved. Now this gets to the point. Sorry, this gets to a point that right now we have standards that's available, which is normally followed in building industries, including insulation. And people might say that we are following it, or what is new about it. With all due respect for ASTM E84, for laymen like me who has no great knowledge about interpreting the test reports, I find it quite difficult to understand what is class A, class B, class C. I mean, okay, it gives a flame spread along the surface. Okay, good. And smoke spread, flame spread index is 0 to 5. Okay, smoke developed is 0 to 20. 450. Okay, fine, good enough. But it finds it's a little difficult for me to interpret this one. Maybe an expert like you or some of you in this forum might be able to interpret, but for laymen like me, it is quite difficult. This is where the advantage of EN standard comes into picture. In the EN standard, it gives very clearly what is the flashover point is. I mean, what is the classification in terms of reaction to fire, whether it's class A, B, C, or D. then you know when you're selecting the material, you know what is the flashover point of the material what you're selecting. Second thing, it also gives the details about smoke. And I like to pass here. This is my personal opinion. Even this is little subjective because it says a little to no smoke. Maybe if you read the report in detail, it gives the value, but on the surface level, on the result wise, it gives only S1 or S2, which is not quantitable, which is, it doesn't quantify with any numbers. But okay, still it gives a value. And if you want to know more about it, it is there in the test reports. We can refer back. It gives a value about smoke, and importantly, it also gives a value about droplets. What is droplet? Just to touch upon it, droplet is that once we burn any plastic material, for example, when we burn it, we tend to see that as it burns, flaming or melt that falls down. And imagine this is a flaming one. If it falls down, it will start a new fire. It will ignite the another material which is the ground floor, right? Now this is very important, so that we understand what is the droplet is also. We look for the material which has no droplets, because if you have a droplet, it means that this material has become a source for another fire. Also, you got my point. I mean, if it melts and drops, it becomes a source for another fire. Now we look for the materials that has almost no droplets or no droplets, because that means that you're not igniting any new fire. Okay, that's why we from KIMMCO-ISOVER, we recommend to look for the latest standard, and which which gives little more detail, which is easy to interpret and gives a good understanding for any layman about the building behavior of the, fire behavior of the building material, especially the insulation. Okay. Now, the same FM Global report also states that if you have effective fire protection and prevention methods, in that kind of with that, you can really reduce the impact of fire on environment and the safety, and it can be controllable. It's a very positive news. Now, all that we need to do is that, yes, if you don't consider things, there is a risk, but definitely there is an opportunity where we can make green building absolutely sustainable, when even though if there is a fire, we can control it. We can control the impact on the environment. We can control on the impact on the people. Okay, that was the first session. Very intense on fire, I hope so. All right, good. Now, I like to recall the slide which we presented at the starting of this presentation. Yes, the same slide, where we are talking about how much of energy is consumed by HVAC. Now, part of this HVAC is ducts, which is one of the critical component, where any kind of energy efficiency that we need to work on, ducts will have a significant impact on the overall HVAC's performance. Quickly, what is duct? Duct is the chamber that takes air from one region to another region. And what are the types type of ducts that's available in GCC? We have metal ducts, which is made up of metal. We have pre-insulated ducts. Under pre-insulated ducts, we have plastic and glass wool based. And we also have flexible ducts, but we will be not talking about flexible ducts in this presentation, because normally flexible ducts are used for a very small area, or for a very small requirements. Okay, I will quickly play this video just to show you how GI ducts are made. Okay, now this. Okay, in this, from a big metal sheet, required metal size are cut. Normally in GI duct, taking the scale of work, nowadays people prefer to have it mostly automated. In this, if you look here, the metal is cut, the sheet is cut from the big roll, then they try to make the required cuttings and bendings that is required to hold the duct together. Can you see here? This is the different types of bendings to have the rigidity, rigidity, and making a provision to seal this duct. I'll just show you. Okay, now these ducts are folded. Okay, now this corner is this corner will be sealed manually or using machine later. But this is one of the type, and also is another type is that they will also have a join here. If it's a big duct, we'll make one L first, and there's a second L that will be made later. That is how normally they make GI duct. I like to show a small video how they make a pre-insulated duct. Pre-insulated duct is the duct which has insulation in the core and vapor barriers on the either side, vapor barrier or acoustic things on the either side of the insulation core. Let's quickly look how they make pre-insulated ducts.
The easiest and quickest duct assemblies to produce are straight rectangular ducts. Every cut must start from the male shiplapped edge of the ductboard and work towards the female shiplapped edge. KIMMCO MM tools and KIMMCO square ruler make the manufacture of these ducts much simpler because the ductboard does not need any guidelines written or masked on the ductboard surface. The KIMMCO square ruler is actually used as the cutting guide. The red MM tool is used 3 times, and the final cut is made with the blue MM tool.
Okay, and this video is about a glass wool based pre-insulated duct, but the principle in general is same. Whether it's a organic based or glass wool based, the principle is same. We have the insulation material, we make grooves, and we close this 4 things to make a duct. Now, whether we do it manually or it can be done using CNC. The second point here is that when we join this one here, he has done it with the stapler, but if you look at the organic base, there might be a different way of joining it. Maybe they might use glue, but in principle, that's what I want to say. In principle, it is more or less the same. Only thing is that how they do it might be different, but in principle, both are is the one what I wanted to show here. Okay, let's look at the next point. Why do they insulate these ducts? They insulate these ducts primarily for the 2 reasons. One is to have the energy efficiency part, which is to reduce the heat loss and the gain. Along with that is to reduce the condensation, the risk of condensation. And the secondary function is to have for acoustics. These are the 2 broad categories, the broad reasons why we use insulation in the ducts. Okay, very quickly to see what is the primary functions. Yes, as I mentioned, it gives thermal comforts, energy saving, a lot of benefits if you have energy conservation in short. But I'd like to mention one point here. Insulation also reduces the risk of condensation. If the risk of condensation is related to your related to your sick buildings, the damp, the indoor air quality. Yes, those things are a concern, especially when we talk about green building, not only green building, for any buildings. Okay, with the insulation, we can definitely reduce the risk of condensation and the associated problems with that. Okay, very quickly, that was the slide. Now we will see a little more in detail how this primary function of energy conservation is done in metal ducts, plastic and or plastic based or organic based PID ducts. In the metal ducts, they insulate the ducts with the additional layer of insulation. This metal is a good conductor, so to achieve the energy efficiency and to reduce condensation, we need to have an additional insulation wrapped around it. This insulation material can be organic based or inorganic based, like glass wool and stone wool, organic based, metal rubber and polyolefin. But whereas in PIDs, there's no additional insulation is required. As I mentioned earlier, the insulation itself is folded or made into a duct form. Now, important point, wherever the insulation is involved, please look for the fire performance of such materials. Wherever the insulation is involved, at least look for a class B S1 D0 rated products, so that you are considering the fire factors when you are deciding the insulation materials. Now, this is interesting. And adding to the energy conservation, there is another topic, which is air tightness. Ladies and gentlemen, this is quite interesting slide. If you look here, this shows what is the impact of energy, air leakage on the energy efficiency. Okay, I like to focus on this first, then let's go there. See, this is a naked duct, means normal GI duct, and it has a portion of heat loss because of no insulation, and there is a portion of energy wastage because of leakage. In GI duct, normally it falls between class A to B. Some very early it can reach class C, but normally it is class B. Okay, if it is a class B, 5% of the air gets leaked. 5% of the air gets leaked, and whereas in glass wool based pre-insulated, it is as low as 0.24%. Now, in case if you want to reduce this loss, you can add insulation and can reduce it. This can be more or less in equal with your glass wool based pre-insulated ducts. It can be, definitely you can manage this loss, but there's a big opportunity here. Which is the potential that we can harness with this air tightness. With this, so you need not add any insulation material to it. With the existing one, if you go with the pre-insulated ducts, all that you have is that you need to have an energy efficiency. Yes, with this you can have this energy efficiency by controlling controlling the air leakage. You need not add any combustible material into the product. You need not worry about the fire performance of those insulation materials. Yes, if you have a better air tightness, you directly add to the energy efficiency. There's a big opportunity here when you compare to GI duct and pre-insulated duct. There's definitely a big opportunity for us in terms of energy saving in controlling the air leakage. Okay, right. Now quickly look into the secondary functions, which is acoustics, and let's see from where these noise are coming from. In the acoustics, the noise are normally coming from the machines while running them. While AC is running, you will get a noise from the machine. Second, from the vibrations, and third, the turbulence that happens during the air circulation. And sometimes we get to hear the noise from the grills and diffusers, but this is independent of ducts. I mean, this is morely related to grills and diffusers. That is nothing to do with duct. Okay, now how this secondary function acoustics achieved in the ducts? If you look at into GI ducts, they insulate the inside layer of the GI duct along with the outside, so that they can reduce the noise that is going through this duct. They add an additional insulation inside the duct to reduce the noise moving through the duct. Okay, the case is same with pre-insulated ducts, organic based pre-insulated ducts also. Since this is also a rigid material, you need to have a porous material to absorb sound, to take the sound attenuation. But since plastic based is also similar to GI duct in terms of structure, they also need an additional insulation to achieve the acoustics. But whereas in glass wool based, you can have it. Just look at this video and then we will check about it. I don't know whether you can hear the noise. I have eyes on the sound meter here. I don't know, in case if you guys are messed out, see, roughly from 80 dB, it can go down to 50 dB, 51 dB close to. This is with glass wool based pre-insulated duct, since the material is made with the porous material, and the inside lining of this material is different. It is not it is what you call a sound absorbing layer, which is inside this duct, which absorbs the sound. But in case of metal ducts and pre-insulated organic based pre-insulated, in case if you want to have the acoustics treatment, you should need to have the additional insulation inside it, or still, if you don't meet the required acoustic comfort, you need to go with additional equipments like air duct noise silencers to be added along with the duct line, so that can reduce your noise. Okay, another point I want to highlight here, as the picture speaks, with all due respect to the people who are working here, we can't blame them, ladies and gentlemen. This is how the material is. GI duct is heavy, and if you see here, this GI duct is without any insulation. If this is with the insulation, the weight will go much more higher. But with the pre-insulated duct is absolutely lightweight. Only 2% can work, as you see in that picture. If you put some numbers together, it is 50% lighter in terms of weight compared to GI ducts. No special cranes or fixtures is required to install this pre-insulated ducts, like how it is required in GI ducts, because it's quite heavy. You need a larger scale of equipments to put it up, and it needs less angers and accessories, because the weight of the system is 5 times lighter. You can see that a person is carrying the big length. If you see roughly, this is 4 meters. He is just carrying by himself. Okay. Now, I like to summarize what we discussed so far in terms of challenges what GI duct has. One is on the insulation and energy saving, because to have the better control over condensation, better control over energy loss, you need to have a better insulation. I mean, you need to have an additional insulation to achieve this. But whereas in pre-insulated ducts, it is inbuilt, and you can also be sure that whatever number it has been mentioned by the manufacturer when he produces a pre-insulated duct, it is achieved. But I don't know how to say it. Sometimes consultant and specifier might specify right products, but during the course of time, because of whatever changes or reworks that is required, they might change the insulation specification to match the requirement, to match whatever it is. But those things are not possible with pre-insulated ducts. Once you finalize pre-insulated duct, it has a specific K values. It will have the specific densities, specific thickness, and when we supply or when we buy the pre-insulated duct, it is remain same. So we cannot, the contractor or the installer cannot change the material, cannot change the specification of the material. Okay. Second things on air leakage. As 5% against 0.25%, this is best in class. Without adding insulation, you can save energy efficiency. It's a quite big number, as you saw, close to 67% of energy can be saved. Third, on the weight, which is 5 times less, weighter and faster you can install. And last but not least, acoustics. It has glass wool paste pre-insulated duct has inbuilt acoustic benefits with that. Now, don't forget, let's look into the 5 factors when you're selecting any insulation materials. At least look for class B. Now, this gets to the last session where we will quickly discuss one of the glass wool based pre-insulated duct that's available in this market, which we are producing, which is called KIMMCO-ISOVER. This is the first of kind in this region where we are producing glass wool based pre-insulated ducts. And we are producing this in Kuwait, where I'm talking from, and it comes in the two types. One is on plessa, which means that on the top side we have aluminum facing, and the inside is also aluminum facing. And the netto, your top face is outside. What you see from the outside is an aluminum, which acts as a vapor barrier, and inside it's an acoustics one. This was the one which helped to achieve the required dB in that video which we just saw, right? There was a alarm clock going inside and out. We use this material to demonstrate how efficient it is in terms of acoustics. Okay, now this product, let's look into two criteria. What we discussed, what is the 5 performance of this, and what is its contribution towards green building. If you look at the fire and the material side, yes, it is class B S1D0 as per EN standard, what we had discussed so far. And this is on the material side. I mean, you look at the system wise, yes, it is UL 181 certified. And we have done, UL 181 also checks on the fire durability and almost 13 other tests on the system, on the glass wool pre-insulated system, and we have this UL 181 certification for this KIMMCO-ISOVER. Okay, quickly, what is its contribution on the sustainability? To create the base for the next slide, I like to spend a little very quickly on this slide. KIMMCO-ISOVER, first of all, KIMMCO-ISOVER is third-party verified product for EPDs. I mean, it has a verified EPDs by the third party. It also has LCAs. Just to give a very little brief so that I can create the base for the next slide. The LCA, what we worked is on cradle to grave, which means right from the sourcing to the production to the transportation of materials to the construction and demolition, the usage and demolition. We have considered every aspects in our LCA analysis. In short, for in layman terms, what it means that we take this inputs wherein LCA assesses the consumption of inputs, which is in this case natural resources, energy, and water, and evaluates what it releases after processing these things. For example, okay, let me put it in simple. Let's take the input of natural resources, energy, and water. These inputs, when you look into the production, after going to production, what it releases, how much of carbon it releases to the air, to the or the emissions to the air, water, and the ground, and what is the wastage produced. And we analyze this under different environmental impact. Similarly, again, take the next input, natural resources, energy, and water. Then we apply that to the construction and see what is the output. Then we collect all this and we put into a map. These are the different impacts that can have, the environmental impacts that LCA analyzes. If you see in almost every segment, in almost every environmental impact segment, KIMMCO-ISOVER is at least 20% better than GI duct. See, for example, if you look here in terms of resource depletion, metal duct, I mean, if you compare to metal duct, it is close to 80, 89, 90%, 86% better. In terms of global warming, it's close to 25% better. In every impact, in every environmental impact criteria, KIMMCO-ISOVER is better. So what I like to say is that not only in terms of its performance in the building, it has energy efficiency, but during the production, during its production, during its usage, and during its demolition, it has altogether a very positive impact towards environment. This KIMMCO-ISOVER has a real positive impact. This can be a very good component into your building, green buildings. Okay, I just want to highlight this one point on the air leakage part, just to give some kind of a translation, because I did not use this slide earlier along with air tightness, because this was done with KIMMCO-ISOVER, so I don't mix it together. Okay, if you look at KIMMCO-ISOVER, it says that it saves quite a lot of energy in air leakage. If you translate that into real numbers, it means that close to 30 tons of carbon dioxide is saved compared to a GI duct. That means if you are insulating a 1,000 square meter building, a building office, and if you use KIMMCO-ISOVER, and the air leakage part alone can save you close to 30 tons of carbon dioxide. In terms of electricity, it is something like using 4,000 people's electricity for 24 hours. And look at this steel part of it. If the same thing, if you want to make it in metal duct, it would have taken close to 3 tons of steel, and it needs the insulation to add over it. And after demolishing, we need to scrap, or we need to dismantle this 3 tons of steel. All these things are not required once we go with KIMMCO-ISOVER. And this gets to another important points. What is its contribution to the leads? It can get up to 42 points. It has all the required certifications like Green Guard, USEP, and it has required EPDs and LCA. It can be a good component in your sustainable building solution, systems. And this gets me to the last slide. We have a lot of online softwares, that is free to use softwares online, which you can which will help you to make your designs. One of the example is Acoustics. We have a software. You can see the link here, where in that you can estimate what is the dB that will have the reduction of dB that you can achieve with KIMMCO-ISOVER, or you can achieve with other ducts materials. We have BIM objects, we have dimensions, KIMMCO dimensions, where it will enable you to design the exact duct sizes that will reduce your frictional losses, or the exact dimension that is required. So these are the softwares that's available, which will help you to design the system efficiently with KIMMCO-ISOVER. So the last summary, ladies and gentlemen, this is the last slide. I'd like to take a note of this. Building must focus on people, environment, and wealth. When I say people, this includes the fire safety into it. It includes the comfort. It includes the thermal comfort. It includes the acoustic comfort, the indoor air quality. When we construct, let's consider everything together, including the fire safety into it. Green, it doesn't mean that just by adding all the green materials into it will make the building sustainable. No, we will look much behind adding green materials. Let's also focus on other things what we discussed today, like easy way of energy saving, like air leakage or fire safety. Even these things are important to be considered when we are picking up the right materials. And last not the least, let's build the buildings must be suitable for all throughout its life. I mean, it's not a temporary solution. After we build, we take care of the building so that it during its lifetime it doesn't have any kind of an additional impact like how we saw in the terms of fire. Let the building be sustainable to the entire lifetime of it, right from its creation till its demolition. That's the last slide. Thank you for your patience, and hope so that we added some value to your time. And we are open now for questions and answers. Thank you.
Thank you so much, Satish, for the wonderful and informative webinar presentation that you gave us today. It was really interesting to see how you tackled the different aspects of ducting in terms of fire safety, acoustics, and energy savings as well. So I think it really goes to show that with one sustainable product, you can achieve a lot of co-benefits that is not only based on one aspect of a green building, but tackles multiple issues at the same time. So thank you so much for the information. So Satish, we have a question that came in. So I'm just going to read it out loud to you. So the question is, what is the thickness, or the usual thickness, I would say, of installation in pre-insulated ducts?
Ashok, you like to answer, please?
Yeah, Jason, I will answer that. Thank you everybody for your patient hearing. As Satish said, I'm hoping that we have added value to the session which you have all attended. And the question which was just asked, I think the answer is simple. The pre-insulated ducts are generally made for internal ducting up to 25 mm thickness.
Okay. So you can specify the insulation thickness up until 25 mm, correct?
25 mm. Yes, that would be the right way to go about it to avoid the condensation issues.
Okay. And what is the typical thermal conductivity? So you use glass wool for your the insulation inside. What is the typical sort of thermal conductivity values that you're looking at?
Yeah, generally the glass wool range is between 0.030 to 0.035. The KIMMCO-ISOVER product line is 0.032 watt per meter Kelvin.
All right. And this is another question. The thickness, the 25 mm, is it suitable in terms of achieving the required 0.3? Is that the maximum sort of U value, or is it like based on like an average of, depending on the thickness, obviously the U value also changes, the thermal conductivity changes. So
no, the thermal conductivity is constant for the density of the material actually. So the thermal resistance will change according to the thickness of the material. So in internal ducts, so that is where pre-insulated ducts are majorly used. 25 mm is more than enough. actually to cover up for the condensation losses. Of course, when you are looking at external ducts, yes, the thicknesses will increase.
Okay. Another question just came in as well. Can PIDs basically be used in outdoor ducting?
See, the concept is that there is a pressure rating for all pre-insulated ducts. So within that pressure rating, you can use it. Now, if we need to check the thickness, what is being specified for those external ducts, and also the pressure rating which is flowing within the ducts, then we can design it accordingly. But on a standard, if you were to ask me that external ducts, generally the market requirements move towards the GI duct, not the pre-insulated. That would be the ideal way, but it's not mandatory.
What is the reasoning behind that in terms of the outdoor ducting being preferably on GI ducting?
Again, going back to the pressure ratings, which is coming. So you are looking at internal ducts, you are looking at pressure ratings below 800 pascals. And that generally comes within that internal segment only, whereas external segments generally tend to go above that particular reading. So then it is more convenient to be using the GI ducts. But if you were to take a building construction, 80% of the ducting would go more on the internal side. Only 20% would be on the external. So you're actually covering up
just
more.
To add to Ashok.
Yeah, Satish, go ahead.
Thanks, Ashok. I mean, just to add to Ashok, thanks, Ashok. It's not that we cannot use it, as Ashok mentioned. Yes, there are products available in the market, and we are also having the product which can be used for external application, provided it meets your design criteria. If it is way too pressures, and as Ashok was saying, that if it is a really a high pressure application, a machine where you need to have a extra rigidity, then we prefer to have it at GI duct. But otherwise, if it is a small machines, definitely we have a product in glass wool based. Also, there are materials in the market with the pre-insulated, organic based pre-insulated, which can be used for external applications. It's not that we cannot use it, but as long as it meets the requirement, yes. But in general, as Ashok said, in general, mostly the pressures are quite high. That's why people prefer to go with GI ducts. Hope so I answered your question, Jason. We answered it.
Yeah, I think that's perfect. Another question is the material itself, glass wool. Is it sensitive to moisture? Can any sort of condensation have an effect on the material
No,
itself?
Jason, the pre-insulated material which you are using, KIMMCO-ISOVER, we are having vapor barriers on both sides actually, so it is not exposed to moisture at all. We've got a 170 micron thickness aluminum foil on the outside, and on the inside we've got around 80 microns. So there is no chance of moisture absorption happening with the glass wool with the KIMMCO-ISOVER ducts.
Okay, and but for in PIDs in general as well, you're not only limited to glass wool, correct? For insulation, you can have any other sort of insulation being used as well, or is that related to a fire safety issue where you have to use basically insulation that's fire compliant?
That's the key point which we are trying to. That is what Satish's presentation was all about. There are multiple product lines in the market where you can use for PID. You can use the organic insulation as well as the inorganic insulation. The point here which we try to drive across is when we are moving towards a more sustainable building design features, we need to consider even the fire factor for it. With the existing solutions which are there in the market, we can easily achieve what is the requirement for designs on thermal conductivity or thermal resistance with whatever is available in the market. But when it comes to sustainability, then it becomes a question mark. That is where a product like KIMMCO-ISOVER turns the tide in favor of the consultants and the designers and even the construction industry as such. Because we bring in a solution which is giving you all the comforts for the people, and achieving the requirements for whether it's the Dubai municipality or the civil defense, etc. At the same time, we are also promising the safety of the people. So yes,
Absolutely.
to answer your question, yes, it is possible, but this product actually changes the entire aspect within the ducting.
Absolutely, I agree.
Yes, just to add,
there are many products. Yeah, go ahead, Satish.
yes, as you mentioned, Jason, there is no something called super insulation material which can have all the features. Okay, whether we have best thermal conductivity property, best in what you call acoustics, and best in terms of fire, there is a combination of it. And our as a consultant, as a manufacturer, we like to propose a product which will meet a requirement in addition to what is required. For example, we with this product we meet your requirement, and adding to that you have other features like fire safety. I mean, when you have two materials of which is giving you the same performance, let's look a little more than the performance as such. Let's look at the sustainability part of it. Is this both materials are giving the same performance? Okay, what about the sustainability part of it? What about the fire factor of it? And let's look behind the basic requirements. Now, it's not that the materials are cannot be used, but our idea is to promote that. Let's look behind. We have materials which can add value to your system, not only achieving your system requirement, but it can add value to it. In addition to it, there are materials available. Now that's where we like to introduce these kind of materials, where it gives an opportunity for the consultant and architects where they can look over and above the basic requirements. Like, okay, it's not only that it should reduce the condensation. Okay, this is basic requirement. Yes, there are three materials which can achieve the same, but in addition to that, it can add some more values. So we are trying to get into the market with these additional features which can add value, especially in green buildings, like indoor air quality or like thermal comfort. These are the additional ones which we are adding it along with the existing prerequisite needs of any insulation pre-insulated duct.
Perfect. And speaking of value, one of the questions that just came in as well is talking about the price or the cost comparison to PIDs and sort of GI ducting, or PIDs using organic versus non-organic insulation. So what is the price structure or the price comparison that you're looking at across the board for ducting?
See, Jason, it's a very valid question. If Saint-Gobain is known to make very innovative product lines for the construction. Now, if we were to bring out products which were out of the price range of the market, it would not. I wouldn't even compare it to the sustainability factor of the industry, and that was actually shown in Satish's slide. We should also look at the three P's: the people, the comfort, and also the prosperity of the sustainability cycle. Now, if the product which we are proposing does not fall within the market range which is there, this product will never be used. And what we have compared in the market, when you take the entire whole system, whether it's the GI or the existing organic PID, or when you compare it with KIMMCO-ISOVER, they're definitely giving benefit for the contractor and the client and also the end user. And that is why it is picking up pace quite quickly. It is only our first year of production in Kuwait from last year, and we have already started doing multiple projects all over GCC.
I think it's also one of the key things that Satish mentioned during his presentation that I noted as well is there are other elements that you should look at when making a cost comparison as well. Because sure, maybe it is competitive in terms of pricing if you're comparing it directly to ducting, but then you also have to realize the cost of manpower and the cost of the other extra materials such as the fixtures that you have to make in for the ducting itself, that actually have to be considered within the price comparison. So I believe it's also important to look at that aspect as well. Correct, Satish?
Thank you, Jason. You nailed it. You nailed it. Absolutely right. Now we are not comparing with material to material or duct to duct. It is a total installed cost. What is the cost to the contractor after he completely finishes his work? If we compare those costs to those costs, we are definitely in par with them, or it can be cheaper also. If provided we work it little efficiently, we can be cheaper. But as you said, absolutely right. You nailed it. It is not a material to material comparison or just duct to duct comparison. It is a total installed cost. What is the cost to the contractor that will happen after he completes the projects? What is the, he can definitely improve his margin. Definitely can improve his margin. He has to be a little more efficient, and we can definitely train them in that, in achieving that. Once he does that, he can make significant profits. You are right, Jason. Ashok, you want to add?
I agree. Go ahead.
Fantastic. So one thing that I picked up on as well is that despite only being in production for about a year, I believe, in Kuwait, correct? You've already sort of started multiple projects across the GCC. So in terms of guarantees and warranty, basically of the ducting, do you have any long-term data on what is the expected lifetime of these ductings? What is the guarantee or the warranty that you give for these ductings?
Jason, see, though we have started the production in Kuwait just 1 year back, this material KIMMCO-ISOVER has been there in the market for the last 50 odd years, actually. It has been there in the European markets and the American markets. The technology got shifted to GCC very recently. That's what has happened. But if you look at the projects which we have done, we've done more than 200 million square meters world over, actually. So when it comes to the warranties of the system, when it comes to the longevity of the system, we've got data which will fill everybody. Whoever is questioning it is there. But the advantage has just come into the GCC because KIMMCO has started to produce it locally.
And how does the climate play a factor in this? Because obviously the Northern American and European markets, obviously they're much colder, but over here that we have much harsher climates and much more humid climates as well, depending on the time of the year as well. How does that play an effect into it?
No, if you were to look at specific countries, etc., in Europe or in North American or South American countries like Colombia or in Spain and Europe, you've got this kind of humidity happening, this range of humidity happening all over actually. So this material has been used in these countries for the last, as I said, for the last 20 to 30 years, surviving all these kind of water vapor permissions and air condensation issues, all covered. See, the requirement which when we design, especially for internal ducts, know what is ambient temperature, where is the dew point falling in. So these were the things which Satish showed in his slide. These were the calculations which can assist the consultant or the designer. Whenever he wants to make a design with a KIMMCO-ISOVER duct, he can actually input all the data into that and he can show calculate the thickness correctly for it. So it will fall within this particular aspect. It's already tried and tested with all these conditions.
Fantastic.
Yes, I mean, this is already used in Southeast Asia, where the humidity is more or less like us. The coastal regions like Indonesia, Singapore, Malaysia, the humidity is more or less what we find in Middle East. I mean, especially we are talking about indoor. Maybe the temperature and the dust, what we see here is different. That's why we try to compare it with that. But when you talk about indoor, where this KIMMCO-ISOVER is used, the case is pretty much similar to Southeast Asia and UAE. So this is being tested, Jason. Thank you.
Perfect. One other question as well, just drawing on your experience with the UAE and the GCC in general in large. Is there any sort of specific mandatory authority code in terms of either the building code or fire safety code within the GCC which has a preference of uh, using PID over GI ductwork?
Jason, no. If you go to the chapter 10 of civil defense regulations, you will have the HVAC systems clearly defined there. You can use, they have a certain code for both the GI duct insulation as well as for the pre-insulated duct insulation. It's a separate section. So any material that is actually have to be, I mean, all the insulation materials have to be civil defense approved. There's no doubt on it. So, but the tests are different for the GI ducts and they are different for the PIDs. So in KIMMCO-ISOVER's case, the good thing is that we are certified for both applications, whether it's GI duct or whether it's pre-insulated duct, comply to all the civil defense regulations and also the Dubai municipality regulations. But it's a very mandatory question, and I would like that to be highlighted, because this is one question which comes quite frequently with a lot of the designers and architects also, is they are looking at designing and they don't want to get into trouble later on when if the materials do not have local approvals.
And what about so that was the UAE that you mentioned. What about Kuwait, Satish? How does it work over there? Is it the same sort of situation?
Yes, here also we need to have the approvals from fire defense, fire department. The case is quite similar with Qatar and even in KSA. Now it has become mandatory that we need to have the fire test or fire approvals from the ministry, different types of ministries, based on where it has been used. For example, they like to have approvals from what you call health ministries, for example. If you want to use it in hospitals, yes, we have the certificates for that. So each region has its own requirements. And talking about Kuwait, yes, we have two requirements. One is from the fire defense, fire department, and second was MEW, yes, MEW. That is the second Ministry for Water and Electricity. We also need an approval from them. Yes, we have that. We also have it for Qatar Civil Defense, and we also have it for KSA.
Okay, perfect. Okay. I believe with this, we are just about finished with the webinar. So thank you everyone for joining. Thank you, Satish. Thank you, Ashok, for your expertise and for the wealth of information that you have given everyone today and all the attendees today. So with that, I would like to wrap up the webinar. Thank you all for joining us. And as I mentioned in the start of the webinar as well, we will be sending out a recording of this webinar as well. To all the participants as well as the registered members. So keep an eye out for that in your mailbox. And please do complete the exit survey and webinar. So exit survey as you leave the webinar to inform us of our future activities. And finally, if you have any other questions, please forward them to us at technicalworkshop@emiratesgbc.org. If you would like to have a further chat with our facilitators today. So thank you, Satish. Thank you, Ashok. Thank you once again for your expertise, and have a good day, everyone. Goodbye.
Thank you, Jason. Thank you, EGBC.
Thank you.
For the opportunity. Thank you. Thank you all.